All right, good morning, guys. This is 7.7, exponential growth and decay, and the objective to model exponential growth and decay. So this chapter here has been talking about exponents, and what today is actually looks a lot like 7.7 with the way the graphs curve using exponents. Okay, so here is what goes into your notes, guys. The formula looks the same from yesterday, so please put this down right here where we have this going into our notes and make a really rough sketch of this. Now here are the key components. A is our initial amount. We talked about that yesterday. You have to write that there, that is the initial amount. B, yesterday we called that a common difference. It is also called a growth factor. And it's a growth factor if the number is larger than 1. And that is really important. So that's why I'm having you guys put this whole thing into your notes right there. So I'll draw an arrow here, and then go ahead and put that part right under there, guys. All right. So the other thing that you should put in your notes kind of by this is exponential decay. So just a real quick recap. I'm going to flip back one page. This was exponential growth because the number was bigger than 1. Your B value is bigger than 1. And then this one here, it is exponential decay. And here's the only difference. Your growth factor or decay factor, your decay factor in this case is between 0 and 1. And that's why we should put this part right beside it. So your growth factor is going to be between 0 and 1 for your B value. So if I came up with a problem like y equals, and this is really common today, so this is an important one to go over. Y equals 2 times 3 raised to the x power. Right away, I know this is exponential growth because this number here is larger than 1. The initial amount is 2. The growth factor is 3. Okay, let's try another one here. Let's say that you had y equals 3 times 1/2 raised to the x power. So if I want to look for my initial amount, I know it's 3. If I want to identify a growth factor or decay factor, this is where it's at. This is a decay factor because it's in between 0 and 1. All right, word problems that go with it. You do have to put this into your notes, guys. There isn't very much you have to put in your notes today, but you do have to put this one in. Now, it says that the initial amount, there was 360 billion was spent at restaurants. So let's go y equals 360 times, sorry. So I got my initial amount. Now I need my growth factor. Now your growth factor works like this. If it increases 7%, that means it started off with 100%. So if it increased by 7%, that'd make it a total of 107%. All right. So change a percent into a decimal by moving the decimal 2 spots. So it's 1.07 is your growth factor. And then what? Now we have to figure out time. That was in 2005. And if the trend continues, about how much will be spent at restaurants in 2015. So from 2005 to 2015, that's 10 years later, where the X would be right here, guys, I'm going to replace that with the number 10. And then run that through the calculator. That would be about, let's see if I have it written down here. Let's see, there we go. So run that through the calculator, and it looks like the answer is 708 and then I'd have to label that $1 billion. There it is, guys. Letter B, what is the expression that represents the equivalent monthly increase of spending? So if you want to do the same thing, but you want to do it by month, here's the expression that you would write down. It would be Y equals, same thing, 360, because that's your starting amount, times, you still have a 1.07 as a growth factor. And now here's the thing with your time. So it's 10 years, and then you have to know, well, how many months is that? Well, there's 12 months in a year, and 12 times 10 will give you 120. So 120 would be your power up top here. Okay, so this is really the only other concept we're learning today, and I know it's a bit, guys, but it is important. Please work on putting this into your notes. And then we should have one problem to follow, and that's pretty much the whole lesson, guys. Now the A on this problem, that's like your final answer. That's what your amount is going to be when you're done. P is the principal, that's your starting amount. R is your rate, that's always a percent. So it might be handy to put, after this, put percent. And then expressed as a decimal. N is, that's probably the hardest one. N is the number of times interest is compounded per year. Usually it has the words annually, semi-annually, or quarterly. Those are the three most popular ones here. Annually, you should use the number. Annually happens once a year. That's a 1. No, that's a 1 now. Okay, semi-annually. Is happens twice a year. Quarterly happens 4 times a year. Okay, and T is just time in years. Okay, and there we go. This will be the last one for your notes, guys. Again, sorry that they're so long with the word problems, but put this baby in, and then we're all wrapped up. Okay, so what we're doing is we're looking for the amount or the final answer. And then with this problem, we have principal, parentheses 1 plus R over N, all raised to the NT power, and we'll just fill in like crazy. So when you're looking for principal, you're looking for a starting amount. The principal in this one is $2,000. 1 plus R is your rate. It's always a percent. The percent I see on the board right now is 4.5%. That as a decimal is 0.045 over. N is how many times it happens per year. And I'm looking for compounded quarterly or semi-annually or annually. Compounded quarterly is 4 times a year. And then N is 4. And now your time. Your time in this problem is 18. So 18 years goes right there. It looks like it's going to be a bugger to solve, but it's not bad. Think of PEMDAS. In the parentheses, which is this part, this can be run through a calculator first, and then that answer would be, let's kind of do some simplifying here, A equals 2,000. When you would take 1 plus 0.045 divided by 4, you would come up with and then now we can take 4 times 18 as well, and that's 72. Okay, and these are problems that you typed in your calculator yesterday. You can type it in all at once, or you can do the exponent first. But either way, the final answer here, you should be coming up with all right, so as long as you're handy with the calculator, these problems aren't bad at all. All right, and then so like for this one here, What is the growth factor? You guys remember at the beginning where you're looking for your growth factor or decay factor? First, this is your initial amount, so you don't have to worry about the 34. This number right here is going to tell you if it's a growth or decay factor. And what is the growth factor in the equation? Your final answer would just be 4. And it's surprising how fast a lot of the problems on the homework assignment are like that, guys. So number 2, what is the initial amount? The initial amount is 15. What is the decay factor? You're looking for the number right here, 0.2. The population of a fish in a lake decreases by 6% annually. What is the decay factor? Right there. And actually, if it decreases, that means it should be this. The initial percent was 100%, right? But the population of the fish in the lake decreases 6%. So that means there'd be 94%. Move the decimal 2 spots, and you'd be 0.94. Yeah, that would be the decay factor on that one. Yep. And then this one right here, this is your principal. This is your rate. Make sure you change the decimal on that. Compounded annually, so that means that's a 1. And the time is 10 years. So then you set it up and away you go. All right, that's the whole lesson, guys. Good luck and have a great day.